Hello, everyone. My name is Jorge Aguilar Sanchez, and I'm here with my partner,
Alexander Vaidatis.
and we are presenting our CECS 461 project HDMI implementation on the Zybo C710T board. Next slide. For the agenda today, we're going to be going over the project overview, the implementation, the software implementation, operation, demo, challenges and solutions, and the summary.
We are using the Zybo Z710T to receive a source and then display that source out to a HDMI capable display device. With the DDR3 RAM that is built into the Zybo, we are able to manipulate the video stream coming into the Zybo. The main functions of this project will be the HDMI in and the HDMI out. We'll also be able to change the resolution of the stream, and we'll also be able to stop and start the stream and invert some colors if we needed to. Some of the more advanced IPs we're using is going to be the video timing controller and the DVI to RGB. Some of the known IPs we used in this project that we have used previously were the DDR3, AXI, GPIO, and the UART IPs. Moving on to the new IPs we used, the first is the RGB to DVI, vice versa, DVI to RGB IPs. This IP allows us to transmit and receive HDMI through a 24-bit RGB video data. The next IP we used was a video timing controller IP. This IP formats the timing of incoming videos, and also this is what allows us to stop and start streams. We also use an AXI Video Direct Memory Access IP. This provides high bandwidth direct memory access between the DDR3 memory on the Zybo and the AXI4 stream. And finally, we use the AXI4 stream IP. This receives input and transmits video over the AXI stream interface. This is the IP that can also change the resolution. This is our implementation of our block diagram. As you can see on the top right is the HDMI in. This is where the source will come in, and as the source comes in, it'll first go to our DVI to RGB first, and then it'll get processed through the rest of our system until where it finally will end up at the bottom right, which is our HDMI out, and that is where it's going to head to our HDMI display. Here's our implementation of the actual HDMI onto our hardware. So this is our Vivado constraints file, and then as you can tell, we've connected all our connectors into the constraints to make sure all the hardware is connected. The top is our input, and the bottom is the HDMI out. And here's our pins connected. As you see, all of them are connected to the HDMI and the DDR, and then all our IOs are also in there. And for our basic flow of our software, we start with the video in, and this data is processed by our hardware integration. The DDR memory can manipulate our stream to how we want it to, and this is where we can start and stop our stream. We could also change colors, resolution, and then finally, at the end of our software is where the HDMI out is, and this is what is displayed on the HDMI display that is connected to the out. For our operation, you just need the Zybo, two HDMI cables, a HDMI monitor, and a source that goes into the Zybo. The source can be anything from a gaming console or a laptop or another computer. And once that code is ran, once you run the code and make sure it starts up, you should see colored bars, and that means it's working. At that point, you can follow the user interface that pops up, and you can manipulate the video through that. And here's our demo of our video of our project presented by Jorge.
Hello, my name is Jorge Aguilar Sanchez, and I'm here with my partner, Alex Valadres. And this is our final project for CECS 461 HDMI implementation. As you can see, we already have the project running on SDK. This is the Vivado block design, an IP integrator, and then we launched it into the SDK. And as you can see here, we already have it running in the SDK terminal to enter a selection. And first thing we're going to do is capture the video device. In order to do that, we had to have our board connected into a second monitor, and then it's displaying from my laptop as a RX source and transmitting onto the monitor. As you can see, it's basically mirroring my monitor, and I should be able to play a video. So right now it's in the correct display resolution, but before it wasn't in the correct display resolution, and we can go back and change it to that. It was in default 600 by or 640 by 480, and as you can see, it's like an incorrect resolution, so it doesn't display correctly on our second monitor. But using our menu, we're actually able to change it, so I can change it back into the correct one. Now, we can also grab the video frame and invert the colors. So let's do that. As you can see, it has inverted the colors. And alright, I had a little technical issues there, but I'm back, and I had to reset my board. Now, as you can see here on the top right, the video display is still showing, but now, since I had to reset the HDMI connections due to how it's set up, the display resolution is back at 640 by 480, but I want to convert that back. So this time I'm going to use option 8, grab the video frame and change the display resolution to the scaled resolution that's coming from. And that should work. Okay, now as you can see, it changed it into 1920 by 1080. I'm not sure why it didn't update it in the display resolution here, but now it's scaled to the appropriate thing. Alright, so and now we can print out a color bar test, and then also a blended one into frame buffer number 1. And that's basically it. So we've had some technical challenges and solutions, and just to list them, our first challenge was actually having trouble with getting the project to run. I've had the 2019 versions and 2020 versions of Vivado, although when I was trying to run and open a project, I was actually having a lot of trouble. And I ended up going back and downloading the 2018.2 version, I believe it is. And this actually helped me, because even though I updated the IPs and everything and the other Vivado versions, it still wouldn't fully function. And I would still get errors on when I would run the implementation and stuff like that. So going back to a different version of Vivado helped. And actually, I saw in the forum that the moderators from Xilinx, they actually recommended to go back a couple versions. Another challenge that I had was when we connected HDMIs, we actually had to follow each step in order, because if you don't do that, then the HDMIs wouldn't function correctly, and it would cause problems with like actually trying to display something, because it wouldn't display anything at all. So we actually had to connect our HDMIs first, and then open our SDK terminal, or any terminal, and for the serial communication. And then we'd have to program the FPGA and GDP needed. And then sometimes even when like we had the serial communication working and everything, the menu displaying, I don't know if it was a connection issue, but I would have sometimes trouble with the menu. It would sometimes glitch out, and sometimes my inputs wouldn't be detected. So I would have to like re-put the inputs, and that's why you can see in the video. I actually had to reset it a couple times and then go back and fix it, and then I would just restart everything and show everything for like different steps. But those were our main problems and solutions. Next slide.
In summary, we were fully able to implement our new IPs. We seamlessly integrated our old IPs with the new ones. Our demo fully worked as we wanted it to, and it worked to the best of the ability that we had it used for. And we are also able to fully implement the UI for users. There's our references, and thank you for your time. That is
Thank
it.
you.